Good afternoon. Now to Dequeue, please. Am I audible? Hello. Am I audible to you guys? Can you hear me? Okay, then what's going on? So today we will see another type of queue, which is double-ended queue, or also known as DEC. Can you see the whiteboard? Double-ended queue, or also known as DEC. So as its name suggests, so in this type of queue, you can insert or delete items in both ways. Okay, that means there are mainly two operations. There is no insertion takes place from one end, and deletion can also take place from both ends. In normal queue, what happens? In normal queue, you delete from front and insert from rear end. Right? But in case of that, you can delete from both ends and you can also end from both ends. Insert and delete. Okay, and this is also a linear data structure. So Dequeue has the property of both stack and queue. Okay, that means it follows both echo and LIFO for any operations. Okay, got the idea? Since it has the property of both stack and queue, that means we can apply a date in in undo and redo operations. Like we can use stack for undoing and redoing your documents, right? So similarly, double-ended queue also can be used for both redo and undo operations. Okay. Other than that, we can also use it for CPU scheduling. Okay, queue we mainly use for CPU scheduling. So since it has the property of normal queue also, we can use a double-ended queue for CPU scheduling. Okay, then we can also use it for the palindrome checker. Do you guys know what is a palindrome? I guess in last semester you guys did program for that. palindrome means word you can read from both ends and it will remain same. So for the palindrome checker also, we can use a double-ended key. Okay? So since Dequeue allows insertion from both ends and deletion also from both ends, we have mainly 4 operations here. What are the 4? You can insert at front. You can also insert at rear. Then we can delete at front. We can also delete at rear. From with no color. Okay, so 4 operations. Boy, please remember. Is it better now? Can you hear me? আগতকে ভাল হৈছে নে? নেকিও শুনা পোৱা নাই সৰুকে আহিছে। So in case of double-ended queue, it allows insertion from both ends and deletion from both ends. Okay, and there are 4 main operations. We can insert from front, we can also insert at then we can also delete from front and we can also delete from rear. Okay, then we can also use our peek. There is another operation peek. Normally we also use peek for stack just to see what is the top element, right? So here with the help of peek, you can see the elements at both front and rear element. Okay. Rear element. Okay. And apart from this, here also we check overflow and underflow conditions, okay, before adding or anything. Okay. So insertion here also known as NQ and it's Dequeue. Apart from that, this is just for the normal double-ended queue. Then again, there are 2 types of Dequeue. 2 types of Dequeue. What are those? One is input restricted and other is output restricted. Okay, so what happened in input restricted? Suppose you have a queue. From the name, you will know there is a restriction in the input operation. Therefore, insertion can be applied just in one end, but you can delete from both ends. Okay, you can delete from both ends, but you can insert just from one end. Okay, you can either select front or rear, doesn't matter. Just that you can add items just from one end and you can delete items from both ends. This is your input restricted. What happens in output restricted? From the name itself, we will know that means there is a restriction in the delete operation. Okay, there is a restriction in the delete operation. That means you can delete just from one end and you can insert from both ends. And you can delete from one end. It can be either from the front or rear, doesn't matter. Okay, that's the two types of double-ended queue. Okay, in normal double-ended queue or deck, we can add or delete item from both ends. And again, there are two types, input restricted. If you are implementing input restricted, that means insertion can be done just from one end and deletion can be performed in both ends. And in output restricted means output deletion has restriction. You can delete just from one end, but you can insert from both ends. Is this one clear? Concept বুঝে পাইছেন? Normal queue, front of or delete, rear of or add. But in case of double-ended, you can insert both ways and you can delete also both ways. Therefore, we have four operations: insert at front, insert at rear, delete from front, and delete from rear. Okay. And your Dequeue has the property of both stack and queue. And there are two types: restricted, not restricted. Up to this part, is it clear? এইখিনিলে বুজি পাইছা চাগে? Okay. Nina said yes. You just need to know the concepts. That's the most important thing. Single-ended queue means normal queue. Then we have circular queue. In circular queue, the last node is pointed to the first node again. Okay. So in case of double-ended queue also, we actually use the similar type of logic. Okay. That means we can implement a double-ended queue with the help of circular array. Because say, if you use just the way of normal queue, then again same problem will be exist. What's the problem? Memory efficient. Once it reaches the rear point, it will show overflow condition even though there are some spaces in front, right? So to remove that problem, circular queue was there because last point points to the first node again. Okay, so in double-ended queue also, we use circular queue. Or you can say circular array. So you just say logically, it will looks like this. Or hypothetically 0, 1, 2, 3, 4. Okay, that means here also for any operation, what's the main advantage of circular array? That after reaching this point, we can reset the value of rear to 0 again. Okay, so same case here also we have the facility that once your means element is at the last location, you can reset the value of rear to the 0. Okay, So what happens in NQ process? Remember, we can add from both ends and we can also delete from both ends. So for example, we want to NQ process. That means now we can add from both ends. We can also add from front. We can also add from the rear. Okay, so just like any queue, circular or normal queue, we always set the value of F and R to be -1. Okay, F and R -1 means what? Our Dequeue is empty and we can insert items. Okay, so see, we can either add from front or from here. Okay, so suppose initially we just want to add one item. Means we just need to make means we just need to make it ready to insert any element. Initially we want to insert just one element, so I can set a value of f equal to 0 and r equal to 0, just like the normal one. So this is for the empty. We want to add something. We set the value of front and rear. Okay. For example, this is f equal to 0 and r equal to 0 at this location. And you want to add something. Okay, you have added maybe 2. Okay. Now, suppose you want to insert something from the rear end. This is rear, okay, and this is front. You want to add something from the rear end. That means what? You will add from here. So if you want to add something from the rear, what we do? We just do rear plus plus. Right? We just increment the rear value. For example, I want to add something now. Our R will be at location 1. Okay. Now R is at location 1. Okay. Now, for example, if you want to add something, you want to add one more item maybe. Let's say 6, then you will just simply do R plus plus. Now R will be at 2. Okay, R will be at 2. Okay. This way means we are only adding items from the rear end. So if we want to add something from the rear end, it will just follow the same process, rear plus plus. Okay. Now it's a tag, it's a double-ended queue. That means we can also add from the front. Correct? Suppose now I want to add something from front. But in normal way, can we add something from the front in normal queue? Can we? In normal way, we cannot do anything, right? F equal to simply a 0 location. And there is nothing in front. This is the first location. And I want to add something from the front. Okay. So in Dequeue, we have the provision that if you want to add something from the front, then you will simply decrement the value of f. Okay. That means what? If your f was 0, you can set the value of f equal to 4. That means just like rear can be connected to the first, similarly front can be also connected to 0. It's just like this. It's same thing, right? So whether it is at f equal to r equal to 0, you can reset the value r equal to 0. If r equal to 4 means last location, you can reset the value of r to 0. Similarly, if your f is at 0, you can reset the value of f to be. Okay. So here we reset either r equal to, it is n plus 1 or n minus 1. N is the size. Okay. Number of elements. 1. To reset the value from 4 to 0, what we do? If our R value is n minus 1, we reset the value of to 0. Okay. Then here, if our front is equal to 0, we can decrease the value of front. That means we can reset the value to be n minus 1. That means it will be in the last position. Okay. So since now your F is pointing at location 4, which is 4, we can add one item here now. Okay, that means we can add something here. F equal to 4 and currently R is equal to 2. What idea? Do you want me to repeat again? In circular array, what we do? If our rear pointer is at last location, we can reset the value to the first location. Okay. Now here, if our front is equal to 0, we can decrement the count. That means we can reset the value to be equal to 4. That means what? The main point is, if means since it's a double-ended queue, normally we add something from the rear end. Okay, if you want to add something from the rear end, you will only take care of the rear end, right? If you want to add from rear, it will simply follow the normal key for. We will simply do rear plus plus, right? We will increment rear plus plus. Now, if you want to add something from front end, which is not the general way of adding something to the queue, you will take care of the run counter. You will do run minus minus. Okay. So here, once your R is at n minus 1, you can reset to R equal to 0. And here, if your F is equal to 0, then you can reset it to n minus 1. Is it clear now? Got it? You want me to repeat or something? Got the idea? Do you want me to repeat anything? Just repeat. Okay, this is our front and this is our rear. Okay, initially f equal to minus 1 and r equal to minus 1. Now suppose you want to add something into your D. So in Dequeue, suppose you want to add from rear. So what we do, it's just normal way. We first set the value f equal to 0, then also r is equal to 0. I want to add something here. I will add. Okay, I want to add something. I'll add here. Okay. Next, suppose I want to add one more item. Then I'll set the value r equal to 1 and add it here. Okay. Next, I want to add one more. R equal to 2. It's simple R, real plus plus, right? If you want to add something from the rear end. Okay. Now you have changed your mind. Now you want to add something from the front. Okay. From front means what? It's the first location. Okay, but there is something already there. So if you want to add something from the front, what you will do? You will simply reset the value of f to n minus 1. That means your f will be reset to here. Okay. Now you want to add something, you add. Okay. Now if you want to add some more item, you will decrement the counter of front f equal to 3 and you will add the item. Is it clear now? Yes, no, anything. Next, this is just the insert operation. Now we have delete operation also. So what happens in delete operation? Here also you can add something, you can delete items from both ends. Okay, suppose I'll just write the same. We have 5, 6, 8, 12, and 10. Okay, so currently we have, this is the current position. Our f is at 3 and r is at 3. Now how we delete operation in case of Q? Normal way, we always delete from the front end. Okay, we always delete from the front and we increase the front counter. Okay, to delete anything, we simply increment the front counter, front plus plus. Right? That means what? You will delete this item, f is equal to 3 and you will do front plus plus. Now f is equal to 4. Correct? Now f is equal to 4 after deleting 12. Correct? Now you want to delete one more item. Okay? You want to delete one more item. Now f is equal at 4. Okay? When we delete item, we always do front plus plus, right? But this is the last location. This is the size. And size is 5 and our it's goes to 0 to 4. Now what you can do, same like the rear. you want to delete this item, you will increment the front. That means after 4, your value will be reset to 0 again. And we can delete this item. This is the last item. We implement it with circular array, remember? So circular array is just like this. So if your f is at last location and you have that deleted, then you will increment the counter. That means you are resetting the value to f0 again. So finally, it will be here. Okay, front will come at this point. This is okay. Not function. So is this clear? Normally for Q, we delete the item, then we increment the front counter. So initially F was at 3, F was at 3 and there was an item here. And when we delete this item, we increment the counter. Now F is equal to 4. Okay. Now you want to delete one more item from the front. That means here we are deleting from the front only. We want to delete one more item from the front. Now F is at 4. That is the last location. So you can reset the value of F to F0. Okay. Front plus plus. And you can delete this item. Okay. Now this is the normal way. You want to delete from front. Now suppose you want to delete from the rear end. Okay. So if you want to delete from rear end, here you will do just the opposite. That means rear minus minus. Okay. So if you want to delete something, you will decrement the rear counter. You will do this and R will be at 2. Okay. If you want to delete the item, you will simply delete the item and you will decrement the count. Okay. So in this case, what's happening? What's happening? That means if you want to delete from front, process is say front plus plus, you will take care of the front counter. And if you want to delete from rear end, then you will do rear minus minus. Okay, so here if it is at 4 or you can say n minus 1, you can reset the value f to 0. Okay, you can reset the value here. Got it? So this one, this one, location this one. Okay. So now delete this item. And R is at minus simple one because we did earlier minus minus. Okay. Okay. Now suppose you want to delete one more item. Okay. You want to delete one more item from the rear end. Then again same thing. Here will be at 0. You will delete the item. Okay. Now there is just one item. And now both front and R is at 0 location. Now, suppose you want to delete one more item from rear end. Okay, you want to delete one more item from the rear. Okay, so that means what? At this moment, front and rear both is at 0. Okay, both is at 0. You can consider, let's say there is one more item there somewhere. Okay, there is some more items here. 60. Okay, and maybe your front is at 3, not 0. Okay, just assuming. Okay, and you still want to delete something from the rear. Okay, that means what? Now you can reset the value of r to n minus 1. That means if you want to delete from here, you will delete this here and reset the value of r equal to. Okay. So now you see in both ways, whether it is front or rear, the moment it will reach the last location, you can set it to the first location, and if it is in first location, you can reset it to the last location. Okay, so here if n is equal to 0, that means, sorry, here is at 0, we can reset the value r to n minus. Okay, so that's it. If you want to enqueue, if you want to enqueue, if you want to add something from rear, just normal process. If you want to add from the front end, you will do front minus minus. Okay, add from rear, rear plus plus, add from front, front minus minus. And in case of delete, you want to delete from front, front plus plus, you want to delete from rear, rear minus minus. Just the opposite. Okay, got it? Okay, now here I consider that we have something here. Okay, we consider that something is here. Now if you had like simply 1 and both front is at f0 and r is at r0, that means you already know this is the only element because f is at 0 and r is equal to 0. So if you have to delete that item, it can be like both you are deleting from front or rear, doesn't matter. You can set the value of f to -1 and r2 -1. That means your queue is empty. Okay. So that's it. I hope it is clear to you guys. Just remember this thing. Add from rear, just normal process. Rear plus plus. Add from front, front minus minus. Delete from front, same process, front plus plus. Delete from rear, rear minus minus. Okay, and in any of the situations, we can always reset the value of front and r whenever it is at the last location to first location, or we can also reset it from first to the last location because we just implement it with the help of a circular queue. So it doesn't matter, both ways are correct. Okay, stop sharing ticket. Jadi paisa sampai? Okay. Jyotismay, Vishnupriya, Thoisana, Worship, Potavi, Prasamba, Vivek. Are you guys there? I'll start lab class from 2:30, okay? start math class from 2:30 onwards. And in last class, we did the program for normal queue. Today we will do program to implement circular queue. Okay. Today we will do program to implement circular queue. So Dequeue is clear, double-ended queue. तुम्हारा ऑफलाइन क्लास वाले है गप्पा नहीं बुझी साथ नहीं बुझेंगे otherwise you guys are just simply mute means most of it